So far, when we have created variables, we've only been putting a single number inside them. For example here, x equals 3. So one of the things that makes MATLAB such a nice language for mathematics and for scientific computing is that it has support for vectors and matrices built right into the language. And so I'll explain how that works in this screencast. So basically what we can do is put multiple elements into a single variable by using square brackets like this. So let's say I had these three numbers, 10, 11, 12. Then I wrap them up in square brackets and just have a space in between them, like you see there. And so that generates this vector x, which has these three elements inside it. So a quick word about terminology. We'll use the word vector and the word array interchangeably. So sometimes this might be called an array, other times it might be called a vector. So we have this vector x, it has three elements in it, and we can refer to particular elements inside that by indexing. It's called indexing. We use parentheses like that. So x1 is the value 10, that's the first item in this vector. x2 is 11, that's the second, and 3 gives us the third item. If we try x4, then we get an error because there is no fourth element in our vector. So we start from 1, so the index of 1 here is the first item, and they increment by 1 as we move through the vector. Now you can use the keyword end here to indicate the last item in the vector. So just to remind you, look over here, x was 10, 11, 12, so x bracket end is the last item, which is 12. So one other thing that we can do with this is assign to particular elements of the vector. So let's say we wanted to overwrite the third element and we wanted to instead have the value 100, then we can do that. And so what we've done is we've changed the x variable, but we changed only the third element and the other two were left alone. And we can actually grow an array by doing this. If we say we put the fourth element to 200, now right now there is no fourth element, but we create one by assigning to it like this. So there's a very common thing that one would want to generate a vector, let's say of this form, 1, 2, 3, 4, 5, something like that. So it's very common that one would want to generate vectors like that, and so there's a shorthand notation for it, and it looks like this. You put 1, 5, and so what that will do is just step through all of the integers between 1 and 5, and so we can go up to whatever upper bound we like and generate a large vector quite quickly with this sort of syntax. And so one final thing that I want to show you about this assignment notation. So if we had, say for example, this, then that will generate a vector with three things in it. You can put commas in here instead of just spaces if you would like. The result is the same. And you can also put semicolons, and if you do that, the result is not the same. So if you use semicolons, then you notice that now the vector runs down the page, so it sits in a column instead of going across the page as it did previously. And so what we've done is transpose this vector. So now we have a column vector instead of a row vector. And so the impact of this semicolon here is simply to say go on to the next line or go on to the next row when you're building up your vector. So here is our y vector. You see it runs down the page. There's an operation called transpose which will basically turn it around, rotate it, and that's a single quote afterwards. So if we put y transpose, then now you see it runs across the page. So let's look at that for our x vector. Here was our x vector, x transpose. Now it's the same ordering, but it's running down the page instead.